Hello, Algebra 2 students. Mr. Smith here, talking to you from home. Want to keep you guys on pace and give you a relatively easy lesson to do today. And we just can't really afford to lose too many days in class, so I wanted to get you started here. I'm not going to pause during the video when I explain things, so if you need to stop the video at any point to think of how something factors or breaks down, just pause the video and rejoin it when you're ready. We're going to look at adding and subtracting rational expressions today. These will be like algebraic things. You'll see on the next page what some of that looks like. These are all algebraic expressions. They all contain variables and they can all be factored. And to get us motivated for this mathematically, we're going to compare this to what you may have done in the past. Let's say like in middle school or even grade school when you wanted to add together two fractions. You might remember that in order to do that, you could only add or subtract fractions if they had the same exact denominator. Well, in this case, 12 and 18 clearly are not the same, so we need to find a number that they both go into. So our LCD of 12 and 18 is 36. So I need to change both of these denominators, like from 12 or 18 to 36. And I don't need to really go over this. I'm going to go through this example quickly, right? The 12 is missing a factor of 3 to become 36, and the 18 is missing a factor of 2. I multiply the top and bottom by that, and we end up getting a fraction whose denominators are now the same. Look at the bottom there, 21 over 36 plus 10 over 36. And now they can be added together. So we're going to do that today with algebraic expressions that are rational. So I'm going to show you a little bit about how to find the LCD and then finally how to simplify them. I think I've got 8 examples here plus this introductory one. So 9 in all. Feel free to, skip around if you feel like you're understanding what's going on. This is just meant as a guide to help you get through the lesson without me being in class. So what we're going to do is pretty much the framework for this is you're going to take each of these denominators and kind of break them down. So what I see here is 8 over, x squared minus 2x minus 3 would factor to x minus 3 and x plus 1. 3x over x squared plus 4x plus 3, I think is x plus 3 and x plus 1. Well, you see they have a common factor, which is good. It makes less work for us. There's an x minus 1 that's common, but really the LCD for the whole thing would be, I need to incorporate every single factor that is part of any denominator. So my LCD is basically the x plus 1 that they have in common, but then you've got to wrangle up any other factors that you see. So I see an x minus 3. Let me do a different color. X minus 3 and an x plus 3. So I need to incorporate those as my LCD. And I hope it's apparent that both of these denominators would now divide in evenly into this LCD. They're both factors of the LCD. So what are we asked to do? We're asked to rewrite each factor over the new LCD. So I already had 8 over x minus 3, x plus 1. Well, the LCD also has an x plus 3 in it. So we need to multiply the denominator by x plus 3. I'm going to make that a new color because it's a new factor. And then the 3x was already over x plus 3, x plus 1. Well, what factor is missing from our list there? We have x plus 3, x plus 1. Looks like x minus 3 is missing. It is not common for us to multiply these things out. We don't multiply this out. You just leave it. However, the numerators, what we typically will do if we're adding them together is we will kind of simplify and add together and apply rules of algebra. This problem does not ask us to add or subtract anything. So this problem is done. It just says write each expression over, or write an equivalent expression with the LCD. So that's like an introductory example. Let's do some actual addition and subtraction. I'm not going to read these rules. We're just going to kind of go through them. Maybe I can just quickly go through. I think I should do that. Basically, you're gonna factor and see if they have a common denominator. If they don't, we'll find the LCD. That's what we just did in the first example. And we'll rewrite each rational expression with the new LCD. All right, then, now that they've got the same denominator, we'll just add or subtract the numerators depending on what we're being asked to do. And we'll combine like terms, blah, 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 blah. And then the last step would be maybe that numerator can be factored. And maybe we can cancel factors in the end. It would be somewhat rare, but it does happen. Just like we did in the previous lesson where you have to state what values this thing is undefined for. All right, so we just wanted to kind of take you through that. I'm actually glad I did that. Let's do some work. So you'll always pretty much want to factor any denominator that is present. So let's take a look at example A here. I have 1 over x minus 2 and x plus 1 plus a 5x over, what is that, x plus 2, x plus 1. When we get better at these later in this lesson, I'm going to show less work. Like right now, I'm going to say, well, what's the LCD? The LCD is whatever factors are common, okay, x plus 1, and then there's also an x minus 2 and an x plus 2. Later on, we'll just kind of think that, and we'll add in any missing factors to save work. I mean, mostly for you. It's to save work for you. So now what we'll do is I'm going to rewrite this. I'm going to say, well, 1 over, I need to have a common denominator. So this expression already had an x minus 2 and an x plus 1. It is missing the x plus 2 factor. So we need to multiply its top and bottom by x plus 2. And then plus 5x over, well, this already has the x plus 2 and the x plus 1. It's missing the x minus 2. And now we'll just do the work. This is all over x minus 2, x plus 1, x plus 2. Let's do the math. 1 times x plus 2 is x plus 2. 5x times x minus 2 is 5x squared minus 10x. Let's put it all together. This would be 5x squared minus 9x plus 2. And then this is x minus 2, x plus 1, x plus 2. So now I guess the only other question here is, does that numerator factor? I have a feeling it does. So I want you to think about then, how would you factor this, this trinomial, 5x squared minus 9x plus 2. If you're not good at factoring, you're going to have to do that AC method where you do the grouping. What I'd like you to think about or start becoming better at is being able to factor something. I don't want to say just by looking at it. There is something that goes into it, right? But here's the way that I approach these problems is this. I know that if the numerator is factorable, you notice how we have a 5x squared in the front and a 2 in the back. So I know that if it's factorable, then I'm going to have a 5x in the front and an x in the front. This would have to be like 5x plus something, or and an x plus or minus something. And then some combination that gives us probably going to be like, the good news is there's only 2 things that multiply to 2. It's 1 and 2. And this is not going to be factorable. Okay, so I'm going to take that back. I'm going to hope to not lean so much on having to factor things, but for now, let's just say this is the final answer. Okay. Number Letter B. Let's look again. Start off with your denominators. What are the factors of the denominator? Well, we've got, I'm going to write this as 8y over y plus 4, y minus 4, and then minus 4 over just y minus 4. Now, what is the LCD? Well, the LCD, well, I've already got a common factor of y minus 4. It's just that the fraction on the right is missing a y plus 4 in the top and the bottom. So I'm going to do that. I'm going to do y plus 4 in the bottom, and however I treat the bottom is how I have to treat the top. So I'm going to have a new answer, essentially. My simplified answer will have y plus 4, y minus 4 in the bottom. Isn't that just y squared minus 16? I'll do that in the next step. And then 8y, I'm going to do minus 4y minus 16. Here we go. Here we go. So now, I'm actually not going to multiply the bottoms together. Isn't this just 4y minus 16? And isn't 4y minus 16 4 times y minus 4? So what factor can I lose here or cancel? I can cancel the y minus 4s, and I'm left with 4 over y plus 4. And since we completely lost a factor, we'd have to say, well, y cannot equal 4. Okay. Letter C. This one doesn't need to be factored. It's just two factors. Two small factors that are sitting there. So this one's a little bit easier. I just have 3 over x minus 3. Notice I'm leaving some space here. Over plus 2 over x minus 2. Well, the common denominator, is simply the two binomials multiplied by each other. So x minus 3 needs an x minus 2, and so does the numerator. The second fraction needs an x minus 3 in the top and the bottom. Therefore, my new denominator is x minus 3, x minus 2, and my worked out numerator is 3x minus 6 plus 2x minus 6. And altogether, that is 5x minus 12. And I'm not going to combine the denominator, and that numerator doesn't factor. So we're good. All right. Letter D. You see this becomes fairly repetitive. It's not that bad. All right, my video got cut off. I fat fingered the button on the top of the iPad, so I'm starting over here starting on D again. So here we go. 5 examples to go. This example here in sorry, I lost my tools. There we go. All right, so again, we're going to start by factoring each denominator. So I'm going to get 4 over x plus 2, x minus 2, and then minus. Got to be careful of minus signs when it comes to distributing things. So we're going to write out each expression as being factored. Let's see what's missing. Well, the first fraction is missing a factor of, you see I'm like skipping steps down, looking at both denominators. Each one has an x minus 2. The left one has an x plus 2, but not an x plus 1. So I'm going to do that here. The right fraction has an x minus 2 and an x plus 1, but does not have an x plus 2. So you see these can be actually fairly easy to do. Be careful when doing this minusing or subtract. I hate to say minusing. When doing this subtracting, you may make a mistake here. I'm trying to prevent you from doing that. Let's actually now just combine everything over one denominator. So we have x plus 1, x plus 2, x minus 2, and then 4x plus 4. Careful here, minus 3x minus 6. Oh, look at that. That's going to become x minus 2, which is going to make that factor cancel. And you're going to end up getting, boy, there's really nothing left except for a 1, right? We're going to have a 1 left in the numerator over x plus 1 and x plus 2. And remember, we made an x minus 2 cancel completely from the denominator. So we have to tell the viewer that x cannot be 2. It's not part of the domain. All right, letter E. Let's get started. Same process. We're going to try to work a little more efficiently here. Trying to give you as much information as you might need. Just factoring these pieces here. N plus 3, n minus 2. You know, I'm tempted to factor that numerator. I'm going to leave it because it looks like I could get some canceling there, but I don't think we have to do that just yet. I do see this, though. I'd like to show you this. I have a 2 minus n here and an n minus 2. They're not quite common factors, but do you remember the trick where, let's say you have like a minus b, and you reverse the order of the numbers in a subtraction problem? Do you remember that that's just the opposite? Okay, so if I take this 2 minus n and I switch it to n minus 2, isn't that really just the opposite of that? And can't I take the negative here and make that just become a positive? I hope you see that. Otherwise, you'll have to do it a different way and get the same answer. But now I've got this common factor of n minus 2. All right, so in order to get the common denominator here, well, you see we've got the common factor of n minus 2. The other fraction needs n plus 3. So I'm going to put that there. And let's just multiply it all out and see what happens. So I've got negative 3n. Whoops, don't like that red. Negative 3n minus 9 plus, n plus 3 squared. That's n squared plus 6n plus 9. All over n plus 3, n minus 2. You might get that by foiling out, this n squared minus 6x plus 9. That's that shortcut, a plus b quantity squared. If you don't remember it, you have to FOIL it out. But you really should be remembering some of these shortcuts. They're there for a reason. In any event, I know that negative 9 will cancel with positive 9, and that what's left over in the numerator is n squared plus 3n. Oh, look at that. It's over n plus 3, n minus 2. Now that numerator factors to n times n plus 3 over n plus 3, n minus 2. And I am making a factor disappear entirely. So I am going to have to make a note in my final answer that this is equal to n over n minus 2. However, n cannot equal negative 3. All right. I hope this is making sense to you. Let's take a look. We got 3 more left. Fairly simple one ahead. This is just, I'm going to rewrite this. 11x plus 28 over x plus 4 plus x squared over x plus 4. Oh, geez, we've already got a common factor. Isn't this just x squared plus 11x plus 28 over x plus 4? And that numerator factors to x plus 7, x plus 4, right, over x plus 4. What can I do there? That's right, I could cancel these factors. And really, what I'm left with is just x plus 7. However, x cannot equal negative 4. In calculus, we say this is a hole in the graph, a removable discontinuity. We'll even use that later on in this unit when we're graphing them. When you can cancel factors like that, it actually results in like a hole in the graph. But you'll see later. it's not worth talking about now. All right, 2 more to go. Oh, good. Another one with the same denominator. I like these. I like these. All right, so let's do all of this over x squared minus 3x plus 18. I'm going to go term by term. I'm going to go slow. I don't want to mess up. 5x squared minus 4x squared. Okay, that's x squared. Negative 7x, take away x. Okay, that's negative 8x. And what's left? 3 minus negative 9 is 12. All right, well, what do we have here? That should get, oh, we have that, and we can factor this down to x minus 6, x minus 2. My denominator is x minus 6, x plus, no, x, wait a minute. I think that's supposed to be a, I think there's a typo here. I think that's supposed to be a minus, right? So if you're still with me here, I'm going to go back here. I'm going to change these to minuses. I didn't make these notes, but I'm pretty sure what they're going for here is that this needs to factor. So it's x minus 6 and then x plus 3. And what you get here is that these x minus 6 factors cancel. So my final answer is x minus 2 over x plus 3. However, x cannot equal 6. So sorry about that, but I'm glad we could talk about it together. And then in H, what I like about H is, again, I'm focusing on these denominators. They're basically opposites, right? So what I'm going to do is the following. We're going to say we have m squared minus 6m over m squared minus 1. And then we're going to have 3m plus 2 over the opposite of m squared minus 1. And again, there's that minus sign in between, which allows me to take the negative from the fraction on the right and use that to make that an addition sign. So what I end up getting in my denominator is m squared minus 1. Or so I'll probably just say, you know what I'm going to say? I'm going to say m plus 1, m minus 1. And my numerator is m squared minus 3m plus 2. Take a moment and look at that if it doesn't make sense. However, I do know that this numerator factors. It's going to be m minus 2, m minus 1, and I've already got my denominator. So then cancel, cancel. And my final answer is m minus 2 over m plus 1, provided that m does not equal 1, or m is not allowed to equal 1. All right, I hope that does the trick for you. Take a look at those practice problems, and we'll go over those next time. I'll also take a moment to explain a few if you don't get them, but I hope this was an easy lesson for you, and I'm going to wrap it up here. Thanks, guys. See you later.